Morning, Year 11. Really sorry I can't be with you this morning, but I'm going to go through this lesson like we normally would anyway so that you're not missing out. So today we're looking at speed, so we want to be able to describe and calculate the speed of a moving object. So you might need to pause the video to write down your LO. So your retrieval today is looking back on some of what we've already done. These are questions that you have already completed, so I expect everyone to get at least the first three correct. Okay, how did you do? So the equation to calculate work done is work done is equal to force by distance, and please remember that you must include your units. So work done is measured in joules, force in newtons, and distance in meters. What's our unit of force? That's the newtons, or you could have got the mark if you just wrote down the symbol in, as I didn't specify what I wanted. What is the work done if we apply 7 Newton force and we move 8 meters in the direction of the force? So work done, again, always remember to start with your equation, is equal to force by distance. So the work done in this case is 7 newtons multiplied by 8 meters. The work done is equal to 46 joules. Okay, you could have wrote down Newton meters, but ideally we're measuring work done in joules. You would have got marks for either answer. When you boil a kettle, what energy transfers are happening? All you needed for these last two questions was just to write down the type of energy and what it was converted into. So for the boiling kettle, we're converting electrical energy into thermal. Sorry, that's a spelling mistake. It should read thermal, T-H-E or M-A-L. And the second one, walking up a flight of stairs. So this is the example we did last Wednesday. And for the energy transfers, we're using the chemical energy in our muscles and we're converting that into gravitational potential energy as we move up the stairs. So please make sure to use your green pens to mark all of those questions. Okay, so our learning objectives today we want to look at the difference between distance and displacement. So we've previously talked about these already, so this should just be a recap. We want to look at what is meant by speed, and we want to be able to calculate the speed of a moving object. So this is car. We want to move from point A to point B. If I'm looking at this car, I can say that the total distance that that car travelled is 500 meters. Okay, because that, if I go along with a trundle wheel and I walk along the road and measure it, that's what I get. I get 500 meters. However, distance is how far the object's moved. It's not actually telling me in what direction that car has actually moved. Here the car has moved 500 meters, but there is no mention of direction. So because it has a magnitude, so remember the word magnitude means size, because it has a magnitude but no direction, then we can go back to our very first lesson and we can say it's a scalar quantity. Displacement, however, is the distance that the object moves in a straight line from the starting point to the finishing point, and it must include the direction. So this is in our green box, so let's write it down. So displacement is the distance that an object moves in a straight line. So that's the key word there, from the starting point to the finishing point, and it must include the direction. So you might want to pause the video to get that wrote down in your books. So if we look at it, the distance of that car driving was 500 meters, but actually the displacement is only 380 meters to the east, because displacement just talks about straight lines, but it does give us the actual direction. So because displacement includes both your magnitude and your direction, displacement is therefore a vector quantity. So like I said, we did cover all of this in our very first lesson, so should just be a recap for you. So speed is equal to distance divided by time. Be very careful. In physics, we write down distance as s and speed for it. So in this case, I'm using the letter v for velocity. Okay, we know from our first lesson that speed is how fast an object is moving in a certain distance, whereas we know that velocity includes that direction. So we know velocity is our vector quantity. So for this, we can alternate in the letter v in our equation. So the speed of an object tells us the distance of the object travelled in a given time. Again, your green box, key definition, write it down in your books. Speed is a scalar quantity because it does not involve direction. We are just talking about how fast the object is moving. So in physics, the symbol for speed is v and the symbol for distance is s. I know this will be confusing, so it is really, really important that you write this down very clearly in your book so that you do not make any mistakes. So let's try and do a question together. The car travels a distance of 260 meters in 20 seconds. Calculate the speed of the car. So we start with writing down our equation. So distance divided by time. That's what our speed is. And if we look at our units, that makes sense because we measure speed in meters per second. So that's meters divided by second. Distance divided by time. So we substitute in our in our numbers. So we have here 260 meters. I know that's my distance, so I'll pop it in the top of my equation. And my time, 20 seconds, I'll pop in down the bottom. When I pop all that into the calculator, I get 13 meters per second. Again, please be careful to make sure that you include your units. If we're talking about typical speeds, you are sometimes asked in the exam to rearrange typical speeds in order. So for example, we all know walking is the slowest, so walking is about 1.5 meters per second. Running, we would expect to cover more distance in a shorter amount of time, so we've about 3 meters per second. And cycling, same thing again, we're about 6 meters per second. So that makes logical sense. As I increase my speed, that means I'm increasing the distance covered in a shorter period of time. So a younger, fitter person will generally be able to achieve a faster speed than an older or an unfit person. Okay, so in the exam it is really important that you read exactly what the question has asked you, and these are just typical speeds, these are just averages. So speed also depends on the terrain. So for example, if I'm running uphill or if I'm just running on flat surface, that is going to impact my speed. It's going to impact how fast I can go and at how much distance I can cover. It also depends on the distance travelled. So if I know that I'm only going to go down the road to the shop, or have I to go all the way into town, that kind of idea. So people who are running a longer distance tend to run faster at the start when they're less tired, but as they go on, they tend to slow down. Or some people who are running marathons, they tend to start off quite a slow, steady pace to save their energy and then speed up later on. They don't travel at that exact same speed for the entire journey. So these are typical vehicle speeds. So a car, we're looking at about 13 meters per second. A fast train in the UK, about 50. An airplane, 250. And then our speed of sound, 330. So you can see there that we can increase the speed as we look at different objects. It is different, quite significantly different, depending on the object we're looking at. So sound is obviously going to be change as well. So on a warmer day, it travels that bit faster than on a colder day. So think about our particles. Think about in chemistry when we studied the energy in those particles. If it's a warm day, we know that those particles have already got more energy. So that speed of sound, that sound can then pass through those particles much quicker. Then on a colder day, when the particles do not have as much energy, they're not moving as much, my sound is slightly slower. It's not enough for us to notice, but there is actually a slight difference. So the speed of a moving object is rarely constant. Think about your car. Think about your journey to school. As the bus turns, each time it takes a turn, it has to slow down, speed up. If it's on a straight road, it tends to speed up. If it comes to traffic lights, it has to slow down, it has to stop. So moving objects rarely travel at the exact same speed for the entire journey. So when we are talking about speed, we are usually talking about the average speed that the object has done during that journey. So to make it easier, we calculate, for our calculations, we just do average speed, although we know in reality that would not be realistic. So distance travelled, I want to rearrange my equation. We already can do this. We can either use our triangle or we can just do a simple rearrangement that you would have used in maths. So if I'm looking for the distance travelled is speed multiplied by time. So pause the video and try and do this question yourself. A car is moving at a constant speed of 12 meters per second for 8 seconds. Calculate the distance travelled by the car. So I've rearranged my equation already. Distance is equal to speed by time. So I put in my units. So 12 meters per second is going to go in for my speed and 8 seconds for my time. I pop up that into my calculator and my distance is equal to 96 meters. So when I'm looking at my units, don't forget that this is meters divided by seconds multiplied by seconds, so your seconds cancel out. Distance is equal to meters. So I'd like now that you hand out your worksheets and try and get as many of those questions done as you can.